Hello everyone, Alex here, otherwise known as CoolAl99 with my new contraption. This is a 5-digit door combination lock with input validation and a fully reprogrammable combination. Let's go ahead and show it off here. Always got to press that before we open the doors. Let it know that we want to try opening it. We've got the pin right there, and we have our keypad layout if you need it. Combo is 53143. 5 3 1 4 3. If all went well, we should get a flash from this indicator right here and the door will open. What do you know? The door opened. So let's try incorrect combinations. Some of the combinations I've tried, you can enter the correct combination just out of order and the door would still open. Or you can enter 1 through 9 and the door would open. This one you can't. You have to enter that number. So let's try the correct digits out of order, excuse me. 1 3 5 3 and 4. What do we get? Gave us an error. How about that? Let's just try a random combination of, completely random numbers like 6 2 7. Let's throw a 9 and a 6. Throw a 4. 4 sounds good. No, it said. So yeah, there you go. That's it telling me that I have to enter this combination right here, which will open the door back up here. Open that door. There you go. Door is open. Okay, now let's work with these buttons here. We've got the change combination button, which starts the reprogramming process. So let's go ahead and test that out. Just go ahead and press that button, and let's change the combination to something random like 48956. Sounds good. So just go ahead and start inputting numbers. You don't have to press that one again. So 4 9 8 5 and 6. Now this torch right here will tell us that the new combination is ready to save when it flashes. So you just hit that button and it is now committed to the memory. So let's close the door and try it. Don't forget, gotta press that. Okay. 4 9 8 5. Lastly 6. If everything went well, the door will open. Pretty cool, huh? Now, the other feature that I have, the final feature to show, is the restart button, pretty much. If you're changing the combination and you decide, I want a different one, you can just press this button and it'll restart you from wherever you are in making the new combination. So, for simplicity's sake, we're just going to make the combination 1 1 1 1 1 1, I don't remember. I think I pressed change combo. I will press it again just to make sure. That shouldn't screw anything up. Okay. Get that sign out of the way. Okay. Start inputting numbers. 2 3 4, and oh my goodness, an intruder came in and bumped you. You accidentally pressed 2. No. No. Well, it's going to tell us that those digits, 1 1 1 1 2, is ready to save. We don't want that one. We want 1 1 1 1 1. So press that button right there and start again. Get that intruder out of the room. Lock him out. Let's input the right combination. This light will flash when it's ready. There you go. Save it. and close. We'll enter the combination just to make sure it worked, which I'm 100% sure that it worked. And that's our last one. Waiting for that light to flash. Well, there you go. So there you go. You've seen it go through 3 different combinations and it opened every time. The change combination worked, reprogrammed the memory, and restarting if you entered the wrong changed combination worked as well. It's pretty cool, I think. Walk in through the door, close it from the inside, and we can also open it from the inside, of course. Don't want to lock ourselves in. And when this when the closed door is activated, it can only be opened from the inside. You cannot end the combination and open it again. Will not happen. So only one person can be in the safe at any one time. So there you have it. It's pretty cool, I think. I'm not sure. I'm probably not the first. Obviously not the first to make one, but I think it was pretty cool because I didn't use any videos to help me build this. I just built it all from, you know, knowledge and how redstone works. So how does it work? Well, if you don't really care to know, or you're not really familiar with how redstone works, you can stop watching now. But if you really want to know how it works, see what it looks like back there, keep watching, because I'm going to show you how it works. So let's reset the circuit completely here. Go back to close door. So now it's back to that state we were in when we just started the video, waiting for the combination to be entered. But we're in the safe. Let's go in this door that's authorized personnel only. After all, I made the circuit, so I better be authorized to come in here. Here's the door latch. You press the closed door, it activates this latch, which will keep the door open in this on, in the on state. Keep the door, keeping the door shut. As you can see, it's already shut because, you know, we have to end the combination, open it again. But this button right here will keep it shut from the inside. Okay, so we're going to go through this, and we're going to walk out there, and there's going to be a bunch of crazy stuff going on. It's going to be huge, and it's going to look overwhelming, but it's not. It's ridiculously redundant. I kind of made the same circuit 5 times when it could have been the same circuit used 5 times, and it would have been 5 times smaller. But this is a 100%, you know, it's completely alpha, prototype, first build ever with redstone, and it worked. That's all I cared about, is that it worked. I wasn't really thinking about making it compact or, you know, just minimizing on space. I was just making it work, and it does. So I'm happy with it. I'm working right now on a model that is far, far, far smaller. It works based on a clock pulse. I think it's like a 3 clock, something like that. And that's a pain to synchronize, but it's coming along pretty well. So far, the first digit can be validated, and so just working on hooking up the memory to it and working on from there. But anyway, let's explain how this one works. So of course the first button we have to press is the change combination button, which is located right there. I'm sorry, the enter combination button, which is still located there. What it's going to do is send a pulse to this latch right here. Now when this latch is active, it's going to do a couple things. It's going to throw these pistons down and send a signal over to this latch, which is completely separate, because these pistons right here are native to the first digit validator and only the first digit validator. This latch is completely separate from the enter combination circuit, other than the fact when it's activated, so that these pistons come down, and now the inputs from the keypad can go through there and there to the first validator. Also, it's going to send a pulse to these memory readers right here, which they're just AND gates, simple AND gates. Pretty much, since it's a latch, it activates a latch. These are going to stay on, and anything that an input from the memory was coming to will pass through the AND gates, because that torch right there, when I activate the button, that'll turn off. This one will turn on and send a signal through the wire to the temporary memory registers. These are only used when the combination is being entered for the first time, and they'll be reset when that is accomplished. Let's go ahead and press that button. I'm gonna break through the wall here so I don't have to, you know, go through that long hallway and stuff. So press the button. There you go. As you can see, pistons are down, and the continuous signal to the memory readers. And now, as you can see, like I said, this torch is on, sending a signal to the temporary memory register, which is then going to this little device here. Now, this I actually did watch a video for. I was kind of working on a binary input validator, which was huge. I mean, I couldn't, and even then it didn't work. It was like 95% accurate. So I was like, you know, if there's something that could change binary back into decimal, this would make it so much easier. And what do you know, there is. So I did watch a video on this one, but there you go. It's changing this one from the memory, because remember our combination is now 11111. It's taking that and it's putting it on this line right here. And right here, these devices right here are the validators. These are where the magic actually happens, where it figures out if it's an incorrect or a correct digit. Now it's really simple. Once again, it's just a couple AND gates stacked on top of each other, and we'll look at our the one with the correct digit already waiting to be entered. So the memory input comes in and it turns that torch off. So now when we press the 1, it'll come through from the keypad to this torch and it'll turn that one off too, turning that one on, and there's a sign that says correct input, and it will send a signal up to the advanced circuit line, which is this long line that goes down that way. Now on top here, it's basically the same. You know, this is input and this is input not. As you can see, you know, that line's off and this one's on. They're the opposite. Now the reason that is because we'll look at this one right here, an incorrect digit. The input from the memory is off. This torch is off. So if we press 2, this one's the 2 validator, signal will come through and turn this wire off, which will turn this one on, sending an input down the error received line, which sends a signal to a latch that is located up on the 5th level. I'll go more into detail on that latch later, and it will also send a signal to the correct digit, or I'm sorry, not the correct, the advanced circuit line. That's why this is just called an advanced circuit line and not the correct digit, because both the error and the correct send a signal down it. That is so that even if you enter the wrong number, you can still continue entering digits, so that you can't just by quick trial and error figure out your combination. We wouldn't want the circuit, the entire, you know, validator resetting itself if you enter just one wrong digit. It'd be really easy to get the pin, the combination, if you did that. And that's pretty much it. That's how it works. So let's go ahead and enter that first one. Combination is 5 ones. Boom. Okay. So now these pistons are back up. This latch was reset by the advanced circuit line. When we sent that 1 through, it obviously activated that AND gate down there and sent a signal up through this line. Branching off right here, this is the line right here. This line resets the pistons so that nothing can now come through anymore. And it also activates this latch. What does that latch do? Begins the second circuit. These are now down accepting inputs. They are not down on any of the other layers because we are waiting for our second digit and only our second digit. and it's pretty much the same thing 4 times in a row, which is why I could have utilized the same circuit 5 times in a row, but like I said, first time. So to avoid boring you with the details, I'm just going to enter 3 more ones. So we are on our 5th and final layer. There it is, propagating up. Oops. As you can see, the 5th one is now waiting for an input. So what happens when we do enter an input? Because obviously now that we're on the 5th digit, something else has to happen, right? Yes, indeed. Turn my sounds off. Sound off. Okay. Correct or incorrect entered, it's going to send an input to the advanced circuit line, which this time is delayed rather heavily, 16 ticks, 16 redstone ticks, which is 32 in-game ticks. Now it's delayed so that if an error was sent through, it has enough time to propagate down and back up. Now I didn't have to do that. I don't know why I did. I just wanted to make a common line for an error. Did not have to happen. It just could have gone over here, but I was in a hurry to get it done. I was almost done with the circuit, so I was like, I need to make it go down. No, you really didn't. Anyway, so this is delayed so that the error has enough time to come to this latch. Now here's the latch I was talking about at first. When this latch is on, it will tell this AND gate. This AND gate right here determines the future of the door, if it's going to open or stay closed. I love AND gates, they're awesome. But anyway, if the latch is on, this torch will turn off. What happens then if our advanced circuit comes along? It's going to turn this torch off too, which will turn this one on. Now this AND gate activates this latch up here, which is on default state on. So if the latch is activated, it'll pull up this piston because there's no more current coming to it. The actual advanced circuit input line, which after it gets to this point, it's now a correct combination input, because if it makes it past this point, it will open the door. However, if there's an error, this piston will pull up in time, and the signal will go pass on through thin air and not activate the rest of the circuit. And it's also a self-resetting latch after a rather long delay. It doesn't have to be that long, but you know, it doesn't really matter. And this latch also resets itself after a little bit of a shorter time. Now, to just pretty much demonstrate what it looks like, just in case it was confusing, I'm going to insert a manual error. So we inserted an error at some point in our stream. There you go, the torch is off. This one will flash on when we get a correct input, pulling that piston up, stopping the advanced signal from going through this block and opening the door. That's exactly how it works. So I should get an error light because I manually entered an error. Yep, and the door did not open. Turn my sounds back on. It started raining, so I'm not on off. Okay, never mind. I'm on a single player game because if there's a heavy lag, this machine might not work, and also the view distance, if it's not long enough with this version, it will definitely not work. Let's go ahead and open the door. One. Just enter the 4 ones. And now when it gets past this point, if the signal gets past this point, it's going to do a few things. First of all, it's going to activate this latch right here. It's going to drop these pistons. It's going to pull these pistons up, and it's going to send a reset to the temporary memory registers. So let's go ahead and insert our final correct number manually, so I don't have to go back down there and do it. There you go. You can see this latch is now ready. The buttons that change the combination and stuff, those are now ready to use as well because these pistons were activated before they were up. These pistons are now up, so no more inputs are getting accepted into the circuit. And those are down. And as you can see with a quick glance, there's nothing stored in our memory, our temporary memory anymore. That's that when we're changing our combination and we put in the new one, the old one still isn't stored in these, because if that happened and we pressed enter combination, the new combination would be mixed in with the old one and you'd be getting numbers above 9 and all this random crazy stuff, and you'd never be able to open your door unless you were lucky enough to somehow all of the digits didn't add up to 9, but that would be, yeah, then you'd have to guess anyway. So yeah, there you go. That's what it does. I need to reset this latch right here so that nothing goes to that 5th digit validator. Go ahead and get rid of that wire. There we go. Alright, very cool. So now the door's open, and the other buttons, the other functions, the change combination, all that, those are now available for use. And the door is also open. Very cool. So let's go ahead and take a look at the change combination mechanism real quick. It's also, once again, very large, unnecessarily so, but it worked. This was my very first build. I made this before I made the actual validator because I was working with binary, like I said, and didn't work. Kept not working. But I was able to make this. So all it does is when you press that change combination button, it pulls these pistons out, which accepts now the binary inputs into this circuit. So when an input comes in, you got this input detector right here. Basically will detect any input from any of the lines. So if you enter any number from 1 through 8, it'll notice, or 1 through 9, excuse me, it'll notice. And it'll send it to this latch right here. Now this latch right now is in its off state. So right now, an input will pass through the piston and go to the memory, which, by the way, when we press the change combination button, it wiped this memory. So now there's nothing coming to these AND gates anymore over here that I already showed you. So this memory is wiped. There's nothing in it. So do not press the close door button or you won't have a combination anymore. But anyway, so the input we put in first is now going to walk through or come through these lines right here that go to the memory registers. You can see that one's down, and this one is a big mess over here. I don't even know where it is. There it is right here. Wow. So that one's down too. So the input will have enough time because it's delayed here. The detectors are delayed. So the input has enough time to go on through before this latch is activated. And that latch, all it does is it reverses the state of these pistons. Push that, it'll pull that one up, push that one down. So let's go ahead and enter a 1 into our stream. And I'll do it from here just to avoid, the immense amount of time it takes to travel back. There you go. As you saw, that piston was pulled up if you noticed. That one is now down. All it did was change the state of those 8 pistons. And if we come over here and take a look at our memory, we got a 1 stored in our first digit only. Nothing else in any of the other 4. And so it pretty much just does that 4 times in a row, or 4 more times, excuse me. And I got better at building these as time went along, because I realized, hey, you don't have to make them really far apart. So it got more efficient as time went along and all that. Now we get up to our 5th digit. A couple more things happen than just the circuit advancing. The input detectors right here, they'll send a pulse down this line here. Now this line is the torch over there that flashes when it gets the 5th digit, saying, hey, got all the digits, you can save them now. And it also sends a signal down to this latch. this latch will turn this torch off on this AND gate. Now this AND gate is linked to the restart and done button, and it's there so that when you press the done or the restart button after you've put in your digits, it will go to the manual reset. Or I'm sorry, the master reset. I don't know why I called it manual. It should be master reset. And it'll reset this whole circuit. Now the restart has its own, which will send the signal to the master reset, so that if you're only on the second digit, you can do it, or you're on the third digit, you can do it. It also sends a pulse to the memory reset, which is this line right here. Walks up here, and connects to the memory reset line. This is the memory reset. And notice, if you notice, it's attached to this AND gate. What do you know? Another AND gate. So the restart button will only work if you're in change combination mode, so that you just can't reset your memory when the door's shut or whatever. So yeah, that's pretty much it. I mean, when you press done, it'll reset the circuit, so that you can, if you want to change combination again, you can start again. And it'll also, when you press the done button, these pistons will go back so that it no longer accepts input until you press change combination again. So that's pretty much it. It's fairly simple. It just looks complicated because I made the same thing 5 times. Like I said, I'm working on another model that's more complex, but it's a lot easier on the eyes. It's much smaller and would work on a server with a very short view distance. And that will come in the future when I finish it, if it works. But yeah, there it is. Fully functioning door combination lock. Let's go ahead and enter our last 4 ones. Just get a flash. There you go. Save that pin. Start a combination. Close the door. Boom. Oops. Using a trackpad. I'm not using a mouse. Throw in that combination one last time, just to show you that it worked, even though we've already tried this combination. But good. So there you go. If you have any questions, anything to say, go ahead and leave in the comments, send me a message. Shout out to Reddit, Minecraft subreddit. You guys are awesome. And shout out to people who watched me build this, kept me company. You guys are awesome. Thanks for watching. I'll see you guys next time.